Alright, so here we have a problem that says a bar of solid circular cross-section is loaded in tension by forces P. The bar has length L and diameter D. The material is a magnesium alloy having a modulus of elasticity E. The allowable stress in tension is sigma allow, and the elongation of the bar must not exceed 0.04 inches. What is the allowable value of the forces P? So we are trying to find P, shown here by the red arrows on either end of the bar. And we need to find P such that it doesn't stretch the bar longer than 0.04 inches and that it doesn't cause an internal tensile stress greater than sigma allow. So we need to be able to find the maximum P for each of these two cases, and then we will need to pick the smaller one so that it does not exceed what is allowed. So first we need to find our givens. So first of all, we have L equals 16 inches. And D equals 0.5 inches. And our modulus of elasticity and our allowable tensile stress. And finally, the elongation of the bar. So since this is given in inches, we know that this is not the strain because strain is unitless. So this would be the change in length of L. So let's call that delta L. Alright, and then we need to be aware of what we are finding. So this problem, it is just P, which is the force on either end of the bar. Alright, so let's think about what equations we can use for this. An important one is our equation for stress. It is force over cross-sectional area. And we also have the relationship between our Young's modulus and our stress, which is given by E equals sigma over epsilon. And then we also need to know what epsilon is, and that would be our change in length over our original length. So this is engineering strain. And then for this specific problem, our area is going to be our circular cross-sectional area. So that will be pi d squared over 4, since our dimensions are given with diameter. So these are the equations we will be using. So for the first criteria, we need to find P such that the tensile stress does not exceed sigma allow. So we're going to start with this first equation here and put our variables into it. So this becomes sigma allow equals P, which is our force, over the cross-sectional area. So pi d squared over 4. And since this is the P for just the first criteria, I'm actually going to call it P1. And at the end, we will choose between P1 and P2 for our final answer. And so if we rearrange this, we get P1 equals sigma allow times pi d squared over 4. And if we plug in all the numbers for this, we will get 3338 pound force. So that is our first preliminary answer. This is the maximum P to avoid causing too high of a stress in the bar. And now we will find P for the maximum elongation of the bar. So for this one, we'll be using the other equations. So this one right here with our Young's modulus and our strain. So we're going to rewrite this for our situation. So we have E is equal to, and instead of saying sigma allow, we're going to change this to our force P over our cross-sectional area, which is pi d squared over 4. So we're replacing sigma with all of this. And then this is going to be over our strain, which is delta L over L. And so this P here is our second P that we're trying to find. And now we rearrange to find P2. And when we plug in the numbers for this equation, we get this. So now we need to figure out which one to pick for our final answer. Since both of these are looking for a maximum P, meaning we want the biggest P that we can use to not cause a too high of a stress or to stretch the bar too much. So if the P is too high, then it will exceed what is allowable. So that means we need to choose the smaller P, and that will be P2. So P for our final answer equals P2, which is 3142 pound force.